In Module 2, Lesson 8, we're going to start applying the properties of operations to add and subtract rational numbers. So we'll begin with example 1, which asks us to explain the meaning of the phrase, "The opposite of a sum is the sum of its opposites." We're going to use a specific math example to prove that. And in this case, since all integers are also rational numbers, we're going to use very basic integers to prove this. We'll start with -1, and we'll add 5 to that, which will give us the sum of 4. The opposite of 4 is -4. So now we'll drop down, and we're going to write the opposite of these two rational numbers. The opposite of -1 is 1, and the opposite of +5 is -5. And the sum of 1 plus -5 is -4, proving that the opposite of the sum is the sum of its opposites. We'll use this idea to simplify many of our problems and make it possible for us to solve things without always having to make common denominators and change the forms of our numbers. In exercise 1, we're given an expression, and they're asking us to represent it with a single rational number, which really means that we're going to add these numbers together and get an answer. Before we begin moving things around, which we can probably see would be a good idea, let's rewrite the entire problem as an addition problem so that we can move our numbers around correctly. So -2 2 plus 3 1/4 plus -3/5. And I put that -3/5 in parentheses so that we're not confused by the signs. At this point, since the problem is all addition, we can use the commutative property of addition to move the numbers around. A good way to do that would be to put the fifths together, since we can combine fifths without having to change to common denominators. So we'll start by recopying our -2 2/5, and then we will move the -3/5 right next to it, followed by our 3 1/4. If we had -2 2/5 and we added -3/5 to it, that would take us to -3. And still having 3 1/4 to be added to it. Finally, if we add -3 and +3 1/4, that will leave us with only 1/4. Example 2 asks us to use the number line model to explain and write the opposite of 2 2/5 as the sum of two rational numbers. So first of all, when we look at the number line, we can see if we start at 0, to locate 2 2/5 on the number line, we would go 2 to the right, and then another 2/5 to the right. And that would have us at 2 2/5. Following that same pattern, if we start at 0 and we go -2, and then another -2/5, that would take us to -2 2/5. So what we see then is that a mixed number is really the sum of a number and a fraction. Which will take us to exercise 2, in which we're asked to rewrite each mixed number as the sum of two signed numbers. So negative 9 and 5/8 would be the sum of negative 9 plus negative 5/8. Keep in mind that on the number line, in order for us to find negative 9 and 5/8, we would have to go 9 units to the left, and then another 5/8 of a unit to the left, because negative 9 and 5/8 is in between negative 9 and negative 10. Continuing on with problem B. In the same way, negative 2 and 1/2 would be the sum of negative 2 plus negative 1/2. Because again, negative 2 and 1/2 is in between negative 2 and negative 3 on the number line. Finally, in problem C, we have a positive mixed number. And so 8 and 1/2 would be the sum of 8 and 11/12. Because 8 and 11/12 is in between 8 and 9 on the number line. Continuing on with the same exercise, only backwards. In exercise 3, they give us the sum, and they want us to put it together as a mixed number. So negative 1 plus negative 5/12 would be negative 1 and 5/12. And in question B, 30 plus 1/8 would be 30 and 1/8. And finally, in problem C, negative 17 plus negative 1/9 would be negative 17 and 1/9. As we move to exercise 4, we see that there are some word problems as well. Mr. Mitchell lost 10 pounds over the summer by jogging each week. By wintertime, he had gained 5 1/8 pounds. Represent the situation with an expression involving signed numbers, and then find what the overall change in Mr. Mitchell's weight is. So we first must know how to represent a loss of 10 pounds, and that would be negative 10. And then by wintertime, he had gained 5 1/8 pounds, so we'll need to add 5 1/8 to that negative 10. Now, following the properties that we've been working on, we could take 5 1/8 and we could split it into a sum. That way we can deal with the fraction without having to regroup. So if we rewrite the problem, we would have negative 10 plus 5 plus 1/8. And in that way, we can combine negative 10 plus 5, which gives us negative 5, and then adding 1/8 to negative 5. Keep in mind that if we are at negative 5 on the number line and we add 1/8 to that, we would need to move to the right on our number line. So our answer then would be negative 4 and 7/8, which is 1/8 to the right of negative 5 on the number line. Finally, in exercise 5, they tell us that Jamal is completing a math problem and representing the expression negative 5 and 5/7 plus 8 minus 3 and 2/7 with a single rational number. In other words, he is solving. They ask us to justify each of Jamal's steps and then show another way to solve the problem. First of all, what Jamal must have done was to rewrite the subtraction in this last part of the problem as addition. So he changed it to addition, and he changed the sign of the number after it to its opposite. Next step was that because it is now addition, he moved the negative 3 and 2/7 in front of the 8 so that our sevenths would be together. That was the commutative property. Next, he split apart his mixed numbers. So negative 5 and 5/7 became negative 5 plus negative 5/7. And negative 3 and 2/7 became negative 3 plus negative 2/7. And our positive 8 stayed the same. After splitting those apart, he then combined the fractional parts, moved them around using the commutative property, and the negative 5/7 and the negative 2/7 add together to get negative 7/7, which we know is negative 1. So that was addition. Finally, he added negative 5 plus negative 1 to get negative 6, and then negative 6 and negative 3 to get negative 9, and finally negative 9 plus 8 to get negative 1. In review, you can use the properties of operations to add and subtract rational numbers more efficiently. For example, negative 5 and 2/9 plus 3 and 7/10, which is a decimal, plus 5 and 2/9 equals negative 5 and 2/9 plus 5 and 2/9 plus 3 and 7/10. And these two numbers cancel each other out, giving us 0 plus 3 and 7/10, which is finally 3 and 7/10. And also keep in mind that the opposite of a sum is the sum of its opposites. And there are several examples shown in our summary as well.